Greetings CTM students, welcome to the lesson for 12.3 talking about odds and how that matches up with probability, what we've been learning about in this chapter so far, chapter 12 here. So we're going to learn about odds against and odds in favor of, and some of these phrases are kind of commonly misunderstood in normal people's languages or normal people's understanding of them, so hopefully we can get a better understanding of what odds actually are and what they mean and how they relate to probability here. So let's get rolling and let's define or see what actually equals odds against. So odds against an event happening. Odds against an event is just equal to this. It's the probability of, it's against, so the probability of failure over the probability of actually succeeding, probability of success. And so this is a big thing here. We're going to learn a couple different things here. Odds against is the first one. Why don't I underline that? So odds against an event happening is the probability of failure over the probability of success. Our other big one will be odds in favor of. And so what's the odds against a certain event happening? Let's check out an example to make more sense of that. So let's say, example 1 here, let's say I said to find the odds against choosing a diamond from a standard deck of 52 cards. So let's go back to this, odds against an event happening. So in this case it's going to be the odds against a diamond happening is going to be the probability of failure, so not a diamond, over the probability of a diamond. That's what we're talking about in this question. So the odds against a diamond being pulled. So odds against a diamond equals the probability of not a diamond. That's failure. Not a diamond is failure. Over probability of a diamond. Drawing a diamond would be success in this case. And so what's the odds against this happening? What is the chance of not drawing a diamond here? So you've got clubs, diamonds, hearts, and spades. You could say it's 3 out of 4. That would be acceptable. But you could also say, if we're talking about the total deck of 52 cards, you could say that 39 out of those 52 are not diamonds. So either way would work. I'm going to use 39 out of 52 just so we get a little practice reducing the fraction. But if you said 3 over 4 instead, you caught the shortcut then if you say that. So this would be 13 out of 52 that are actually diamonds. And you could reduce this, or you can simplify this. If you remember from your past math classes, division of fractions. This is just one fraction divided by another fraction. You can change division of fractions into multiplication of the reciprocal of the second one. So you take this and multiply it by the reciprocal of the bottom fraction. That would be 52 over 13. 52 and 52 can cross cancel and become 1 and a 1. So what you're left with is just 39 over 13, or that's 3 over 1. You could just write 3, but when we're talking about odds, we want to have a number on the bottom. Even if that number is a 1, we want to include that number. So the odds against the diamond would be 3 to 1. Or you could write it in a common way to see ratios like this is with a colon like that, 3 to 1 like that. So 3 to 1, or you can write it this way as well. Let's check out a second example. It's still dealing with odds against. So now let's assume you have a lot of t-shirts in your drawer. You have 22 t-shirts. You own 22 t-shirts, and 6 of those t-shirts are green. So 6 of which are green. find the odds against, so in other words, not in favor of, but the odds against choosing a green t-shirt at random. So it's not just, I know there's 16 t-shirts that aren't green. It's not just 16 out of 22. That's the probability of pulling a non-green shirt. But we're saying what are the odds against it. So the odds against is different. We're dealing with the probability of success, the probability of failure over the probability of success. So what's the probability of failure? Well, that's going to be the probability of not drawing green. So let's write down odds against a green t-shirt first. The odds against a green t-shirt is the probability of not green over the probability of green. Excuse me. Okay. So the probability of not green, the probability of green is easier to think of here. It's 6 out of the 22. And we already determined, we said that this was 16 out of 22. That's 22 minus the 6 gives you that number right there. It gives you the 16. But if you didn't see that, you can always think of it like this too. It's 1, the 100%, minus actually getting green. So 1 minus 6 over 22. Now you could reduce this. You could change that and reduce it, or you could reduce later. I'm going to reduce later instead of at the beginning. So this would be the same thing as 16 over 22. So there's 16 non-green shirts compared to 6 that are green. You can do the same thing that we did over here. You can multiply by the reciprocal of that second fraction. So this is going to become 16 over 22 times 22 over 6. This will cancel with this, cross cancel. You have 16 over 6. That's the same thing as, you can reduce that to 8 over 3. So you can write it like that, or you can write it like this. Now you may be noticing something here as we go. This number plus this number, 16 plus 6, after you reduce all that, it equals 22. It equals the total. Same thing over here. 39 plus 13 equals the total that you had to choose from, 52. So some of you may be able to go right to this step, and I'm fine if you do that, honestly. So if you go right to this step and say the not a diamond part, that was 39 that aren't diamonds, over the diamond parts, 13, and then just reduce that fraction, you can do that too. This is the way our book describes it here, and it's totally valid. It's how it actually works out. But if you can think of that shortcut in your head, go ahead and do that. You had 16 that weren't green to 6 that were green. You can reduce that to 8 over 3. Alright, so let's move on though and talk about now odds in favor of an event instead of odds against. So odds in favor of an event happening. All we do is flip the fraction around. So here we had odds against was the probability of failure over the probability of success. We're going to flip-flop that. We're going to take the reciprocal of that and say now the odds in favor of an event happening is the probability of success over the probability of failure. And so that's our other big guy here. Alright, so that's the other really important thing to know for this lesson. So let's say you were given 3 choices. You're part of this group. Suppose a group of people are given 3 choices. You got ballet, you've got opera, and you've got musical. And musical. And that's what we got going on over here. Ballet, opera, musical. Of these choices, no, not 4, but meant to write 2 here. 28% chose ballet. 24% chose opera. And 52%, no, that's what that adds up to, sorry, 48% chose musical. And now find the, this time, odds in favor of. So instead of odds against, find the odds in favor of randomly selecting. I don't know what I'm spelling there. Randomly selecting. There we go. I'm trying to put randomly and selecting together, I think. Randomly selecting someone from this group that chose opera. Okay, so think about this. Odds in favor of an event happening. It's the probability of success over the probability of failure. So odds in favor of opera would be the probability of success would be the probability of opera. Opera we're considering a success in this case. Over the probability of failure, that would be the not opera part. So how many people did not choose opera? So I'm going to put not opera there. And this would be the probability of opera. If you're talking percent, you're talking per 100 cent. Think of cents in a dollar. Think of century. You have 24 out of 100. It doesn't mean there were 100 people in the group necessarily. It just means that 24 out of every 100 people that might be in the group chose opera. And so we have this out of the not opera would be, you could either take 1 minus this, or you could take the things here. Since this is the only 3 choices they had to pick one of these 3 things. This plus this adds up to 100% like it should. So this would be 76% plus 24 would be 100%. Okay, so we have this, which we can simplify this stuff a little bit. Notice I'm not going to reduce the fraction right now here, even though I could, because it'll make it easier in a little bit actually. So 76 over 100 is what that would simplify to. You can now change this to multiplication of the reciprocal, and because of that, this will go away here and here. Because I didn't reduce anything, it kept it pretty simple for right now. So again, notice, like I had said before here with examples 1 and 2, if you notice that this and this add up to the 52, you can go right to that shortcut way and say that that's the case. If you notice 16 and 6 adds up to 22, this is not green, this is green, you can go right to that. If you notice this is the opera part and this is the not opera part and they add up to that 100, then, because we're talking about percent here, then you could go right to this right away. This though reduces, let me write that down here because I think I'm about to run out of room here. This can reduce to, you can divide by 4 and 4 and you can get 6 over 19. You can also write that as 6 with a colon and 19 that way. So that means for every 6 people that chose opera, there were 19 that didn't choose opera. So the odds in favor of opera would be 6 to 19. Alright, one more example, and that will be that for this lesson's notes. So suppose the odds, and I should not say of, I'm going to say odds against in this one. Suppose the odds against the Lakers. Ooh, Mr. Wagner, those are fighting words. The odds against of the Lakers making the playoffs Hey, did I say they were bad? I didn't say they were bad yet, did I? Yet. Making the playoffs are 7-2. So I'm going to say that that's the case. The year I'm making this, it's been kind of a rough year for the Lakers. I thought they were going to do a lot better than what they are right now. Yeah. But anyways, suppose the odds against the Lakers making the playoffs are 7-2. Find the probability of both the Lakers making and not making the playoffs. Making and not making the playoffs. So I just made up these numbers, but these could be odds maybe you would see in Vegas when they're placing bets on sports. Not the best idea in my opinion to try to make a living off of that, but some people do it. Some people are good at it. But let's see what we got here. So the odds against, that is a probability of failure over the probability of success. Failure would be not making the playoffs for the Lakers. So the probability of not making the playoffs over the probability of actually making the playoffs. And apparently this fraction, whatever that is, reduces to this ratio right here, to 7/2. That doesn't mean you have a 7 probability of making the playoffs. This has been a reduced fraction. So what would it look like as kind of a non-reduced fraction? Since the odds statement is, way too much space there, there we go, 7/2. If you were to, in a sense, unsimplify this fraction, what would have been there before? Just like you had 24/100 here, just like you had 16/22 here and 6/22 there. What would be the denominator that would go there? It's always that total number. Here there was 100 total when talking about percents to choose from. Here there was 22 total t-shirts to choose from. Here there were 52 total cards to choose from. So here you've got the total here would be 7 plus the 2. You have 7 plus 2. The denominator has to be that. So the denominator of both probabilities is 7 plus 2, which is 9. Okay, so therefore, probability of failure, that 7 still goes with this. That's the probability of not making the playoffs, in other words. That would definitely be failure for the Lakers. They almost always make the playoffs. So the probability of the playoffs is the 7, but the missing denominator there in both of these, in a sense, if you were to unsimplify this, would be a 9. So 7 out of 9. The probability of making the playoffs should add up with this number to get 100%, or 1. So the probability of success, let's see if that works out then. Probability of success would be the probability of actually making the playoffs. And we said the denominator was 9, so 2 out of 9. And if you add those two things together, 7 ninths plus 2 ninths, you get what you would expect to get. You get 9 out of 9, which is just 1. There should be a 100% when you add up those two things, or 1 when you add up those two things, because they are kind of mutually exclusive things. Either one has to happen or the other one has to happen, but both of them can't happen at the same time. And that's leading us into stuff that's farther on in this chapter, so don't worry about that phrase yet for now, mutually exclusive. But these two things should add up together, because the probability of making and not making the playoffs together is 100%. So that makes sense, and that is that for this lesson. Let me know in class if you had any questions.